Welcome to Formula 1 Maths. This is past exam questions 002 for IGCSE. We've got 3 questions to answer. Question 1. A. Find the value of m in the following equation. So 13 raised to the power minus 5, all of that raised to the power 7 over 13 raised to the power m is equal to 13 raised to the power minus 30. Show you're working clearly. B. Find the value of y in the following equation. Root 3 times 27 is equal to 3 raised to the power y. Show you're working clearly. So for A, this is the equation we need to solve to find the value of m. So first of all, we rearrange the whole equation, take 13 to the power m to the side, and then bring 13 to the power minus 30 to the side of the equation. So when 13 to the power minus 30 comes over here, it divides. So we are going to get this. We will then use the laws of indices, specifically rule number 3, to simplify the numerator. And so 13 raised to the power minus 5, all of that raised to the power 7 is simply 13 to the power minus 5 times 7. And that will give 13 raised to the power minus 35. So we are going to get this for the numerator. Then we're going to use rule number 2 to simplify the left-hand side of this equation. So we are going to get 13 to the power minus 35 minus 30 is equal to 13 to the power m. But this will give us 13 to the power minus 5 because a minus and a minus gives you positive. So we end up with 13 to the power minus 35 plus 30. So we're going to get this. Now we got 13 to the power minus 5 is equal to 13 to the power m. The bases, as you can see, are the same, and that means the powers must be the same. So that means m is equal to minus 5, and that is for A. For B, the best thing to do is write 27 as a power of 3. So 27 is the same as 3 to the power 3. So if you replace this one by 3 to the power 3, we get this. But root 3 is also the same as 3 to the power half. So this equation will reduce to 3 to the power half times 3 to the power 3 is equal to 3 to the power y. Then using the first rule, you can simplify the left-hand side of this equation to get the following. But 3 plus a half is the same as 7 over 2. So the left-hand side reduces to 3 to the power 7 over 2 equals to 3 to the power y. And again, the bases are the same, so the powers must be the same. That means y is equal to 7 over 2. And 7 over 2 is the same as 3.5. So y is 3.5. And that's question 1. Question 2. Given that 7 plus root n times 11 minus root n is equal to 60 plus m squared root n, where n is a prime number and m is a positive constant, find the values of m and n. Show clearly all stages of your working. So the first thing to do is to expand the left-hand side of this equation. To do that, we are going to multiply 7 by 11 and then 7 by minus root n. And we then multiply root n by 11 and root n by minus root n. So if we do that, we're going to get something like this. That will be 77 minus 7 root n plus 11 root n minus n is equal to 60 plus m squared root n. Now root n times minus root n will be minus root n all squared. And that gives us minus n. So that's why this is minus n. Now we have to collect like terms. Minus root n is irrational, and plus 11 root n is also irrational. So we can combine those two. 77 is rational, and because we are told that n is a prime number, n is also rational. So we can bring the rational numbers together and the irrational numbers together to get the following. So we have 77 minus n plus 4 root n is equal to 60 plus m squared root n. 4 root n was got from 11 root n minus 7 root n gives us 4 root n. Now looking at the two sides of the equation, the left-hand side has 3 terms and the right-hand side has got 2 terms. So we can combine these 3 terms to get 2 terms just like the right-hand side so that we can compare the two sides. We can do this by putting brackets around the 77 and then minus n. So we can get something like that. So now 7 minus n forms one term and then 4 root n forms another term, just like the right-hand side. We can now compare the left-hand side and the right-hand side. 77 minus n will be rational, and so we can equate that to the rational part of the right-hand side. 4 root n is irrational, and m squared root n is irrational. So by comparing both sides of the equation, we can say that m squared root n is equals to 4 root n. We can also say that 77 minus n is equals to 60. So using these two equations, we can go and solve for both m and n as follows. So m squared, as we can see here, is equals to 4. Because if I divide this equation by root n, I'll get m squared is equals to 4. And that means m is equals to root 4. But we know that m is a positive constant, so that means m is 2. And from this equation here, you can solve for n. So 77 minus n is equal to 60. That means n is equal to 77 minus 60, and therefore n is equal to 17. And that's the values for m and n. Question 3. The sum of the first n terms of a series S is 630. The third term is 10, and the fifth term is 15. Find the value of n. Show clear algebraic working. So we are going to use this formula here, which is the nth term of any arithmetic series, where a is the first term and d is the common difference. So using this formula, we can do our substitution to find the third term as follows. So we don't know a, we know n to be 3, and so if we put 3 here, we're going to get a plus 2d. But we know that the third term is 10, so we can equate this to 10 and label it equation 1. We can do the same for the fifth term by putting 5 here to get a plus 4d. But the fifth term we know is 15. So similarly, we can equate this to 15 and get this. Then we can label it as equation 2. We've got 2 equations with 2 unknowns. So we can now solve the 2 equations simultaneously to obtain the values of a and d. So I'm going to subtract equation 1 from equation 2. And if I do that, I'll get 2d is equal to 5. Because a minus a is nothing, 4 minus d is 2d, and 15 minus 10 is 5. I can now solve for d to get 2.5. Now that I've got d, I can substitute this value into either equation 1 or 2 to find the value of a. So I'm going to use equation 1, and I'm going to get a plus 2 times 5 over 2 is equal to 10. I can cross out this 2 and that 2 to get a plus 5 is equal to 10. And solving for a will give a is equal to 5. So the values of a and d are 5 and d respectively. So now that we know a and d, we're going to use yet another formula. This time, the sum of arithmetic series, which is given by this formula, where again, a is the first term and d the common difference, and n is the number of terms. In our case, our n is the uppercase n here. So we can go ahead and do our substitution to find uppercase n as follows. So the a we know to be 5, and the d we know to be 5 over 2. So if we do our substitution, we get this. But we know that the sum is 630. So we can equate this to 630 as follows. Then we can solve for n. So we'll go step by step and solve this equation for n. The first step will be to simplify what is in the square bracket. So we're going to get n over 2 brackets 10 plus 5 over 2n minus 5 over 2. So what I've done here is to multiply this by that to get 10 and then expand the brackets inside the square brackets. And then I can go and simplify what is in the brackets. Then I can take 2 to this side to multiply by 630 and also simplify what is in the brackets. And if I do that, I'll get this. So 10 minus 5 over 2 is 15 over 2. And then if I take 2 over 2 to the other side and multiply, I get 1,260. I can now expand these brackets to get 5 over 2n squared plus 15 over 2n is equal to 1,260. But I can multiply every term by 2 to get 5n squared plus 15n is equal to 2,520. I can also divide every term by 5 to simplify the equation to get n squared plus 3n is equal to 504. Then rearrange to get a quadratic in n as follows. Then I can solve this either using the formula or factorizing. I will on this occasion factorize to get n minus 21 times n plus 24. But we know that the value of n cannot be negative. So n cannot be minus 24. So we conclude that n is 21. So the number of terms is 21. And this is the end of this session of past exam questions 002. Thank you for watching, and I'll see you in the next video.